بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Section 3.9 Logarithmic Functions. In this section, we aim to derive the derivative of logarithmic functions and introduce logarithmic differentiation. So first, let us try to derive the derivative of y is equal ln of x and try to derive the derivative of y is equal log x to the base b. So for y is equal ln of x, from previous section, which is section 3.8, we learn how to find the derivative of exponential function. And we know that the exponential function and logarithmic function, they are inverse for each other. So let us write this logarithmic function as an exponential function. So we'll add here e, it will be exponential of y is equal e ln of x. So exponential of y is equal to x. So if you said y is equal ln of x, that means exponential of y is equal to x. So this is another way to write y is equal ln of x. Now let us differentiate both sides with respect to x. So the derivative of exponential of y with respect to x is equal the derivative of x with respect to x. Derivative of exponential of y will be exponential of y multiplied by dy over dx. We multiplied by dy over dx because this function is function of y. We differentiate with respect to x. Derivative of x with respect to x will be just 1. So now we need to put dy over dx in one side. So dy over dx will be equal 1 over exponential of y. Because we divide this one by exponential of y, we will divide both sides. So dy over dx will be equal 1 over exponential of y. What is your y? From the beginning we said it is ln of x. So d of ln x over dx is equal 1 over exponential of y, we said it is x. So 1 over x. So we conclude that the derivative of ln x will be just 1 over x. In the same way we will do the derivative, we will derive the derivative of y is equal log x to the base b. So y is equal log x to the base b, we need to rewrite it like exponential function. So this will be b power y is equal x. So b power y is equal to x is another way of writing y is equal log x to the base b. So now we will differentiate both sides with respect to x. So d of by over dx is equal d over dx of the function x. So the derivative of p power y, we will use the logarithmic from section 3.8. So it will be b power y multiplied by ln b multiplied by dy over dx. So this is the derivative of p power y. Derivative of x with respect to x will be 1. Then we need to put dy over dx in one side. So dy over dx will be equal. So we'll divide by this part. b power y ln b, both sides. So dy over dx will be 1 over b power y ln b. So what is your y? It is log x to the base b. So here we have d over dx. We replace this y by log x to the base b. What is b power y here? It is x. So we'll replace this b power y by x. So the derivative of log x to the base b is given by 1 over x ln b. Or we have another way to evaluate the derivative of y is equal log x to the base b. Log x to the base b, you can write it like ln x over ln b. So now we will differentiate both sides with respect to x. Derivative of y with respect to x, derivative of ln x over ln b with respect to x. So derivative of y will be dy over dx. Derivative of ln x over ln b. Here b is a constant, so ln b will be a number. We can take it out and just we differentiate ln of x. So dy over dx will be 1 over ln b, d of ln x over dx. Derivative of ln x will be 1 over x, and we have here 1 over ln b from the beginning. So the derivative of y, which is log x to the base b, will be 1 over ln b multiplied by 1 over x, which is 1 over x ln b. So either you will use this method and then you differentiate it both sides with respect to x, or you will do it by this one and use logarithmic you will use the derivative of exponential function. So in brief, this will be in theorem 391. If u is equal g of x is differentiable function, then the derivative of ln u will be 1 over u du over dx. We discussed previous that derivative of ln x, that's we say 1 over x. But here derivative of ln u with respect to x, so we'll need to multiply it by du over dx. So the derivative of ln u will be 1 over u, then whatever inside the bracket you have to differentiate it. So that's why we multiplied by du over dx. Similarly, derivative of log u to the base b will be 1 over u ln b, we need to multiply it by du over dx. So the first example, it is question number 10. Differentiate f of x is equal x ln x whole squared. So here we have two functions, x and ln x squared. We need to use the product rule to find the derivative of fx. So y prime or f prime x will be equal derivative of ln x squared multiplied by x plus derivative of x multiplied by ln x squared. So the derivative of ln x all squared will be 2. So here we'll use the power rule because we have all power 2, so it will be 2 ln of x power 1 multiplied by derivative of ln x 1 over x. So here we get 2 ln x 1 over x. This is derivative of ln x all squared multiplied by x plus derivative of x 1 multiplied by ln x all squared will be ln x squared. Then here you can cancel x with this x, so you left with 2 ln x plus ln x all squared. Example 2, find the slope of the tangent line to the graph of y is equal log x squared to the base 5 at x is equal to. So here we need to use the second rule. So dy over dx, we'll add d over dx for both sides. Dy over dx is equal d over dx of log x squared to the base 5. We can rewrite log x squared to the base 5 as ln x squared over ln 5. So now we will differentiate both sides. Derivative of y will be dy over dx. Here we have ln 5 is a constant, so we take it out. Just we need to find the derivative of ln x squared. So 1 over ln 5 will be the same. Derivative of ln x squared will be 1 over x squared. We need to multiply the derivative of what is inside ln. So inside ln is x squared, so the derivative of x squared will be 2x. So now dy over dx will be 2x over ln 5 multiplied by x squared. Then we can cancel x from here with 1x from here. It is equal to over ln 5 multiplied by x. We need to evaluate it when x is equal to 2. So we need to replace this x by 2. So dy over dx when x is equal to will be equal 2 over ln 5 multiplied by 2. Then you can cancel these 2 with this 2. You left with 1 over ln 5. Example 3, differentiate y is equal ln sin x. So we'll add d over dx for both sides. It will be dy over dx is equal d ln sin x over dx. So the derivative of y will be dy over dx. Derivative of ln sin x, we will take what is inside ln, so it will be 1 over sin x multiplied by, inside ln is sin x, so we need to multiply by the derivative of sin x. So derivative of sin x will be cosine x. So we have dy over dx will be cosine x over sin x, which is equal cot x. by is equal ln x. So we'll add d over dx for both sides. Here we'll have dy over dx. Here we'll have d ln x over dx. Derivative of y will be dy over dx. Derivative of ln of x. Let us go with bracket by bracket. First, we will differentiate with respect to this ln, the outer one. So it will be 1 over what is inside ln of x. So 1 over ln x. We multiplied by the derivative of this bracket. So the derivative of ln x. So we have 1 over ln x multiplied by derivative of ln x will be 1 over x. So we conclude dy over dx is equal 1 over x ln of x. Then see we have f of x is equal ln x power 5. So dy over dx, we will add it for both sides. We have df of x over dx is equal derivative of ln x power 5 over dx. Derivative of x will be f prime x derivative of ln x power 5. So what is inside ln x power 5? It will be 1 over x power 5 multiplied by the derivative of the bracket which is inside ln x power 5. So the derivative of x power 5 will be 5x power 4. So f prime will be 5x power 4 over x power 5 will be 5 over x. Here we need to compare what is the difference between y is equal ln x and the derivative of y is equal ln x and the derivative of y is equal ln absolute value of x. So we have y is equal ln of x. We know that the derivative is equal 1 over x. We need to know what is the derivative of y is equal ln absolute value of x. So y is equal ln absolute value of x. Let us redefine the absolute value. So it will be ln x when x greater than 0, ln minus x when x less than 0. So y prime will be equal derivative of this one when x greater than 0, derivative of this one when x less than 0. So d over dx of ln x, d over dx of ln minus x. Derivative of ln x will be 1 over x. Derivative of ln minus x will be 1 over minus x multiplied by derivative of minus x. So this one will remain the same, 1 over x. This one will be 1 over minus x multiplied by derivative of minus x will be minus 1. So minus 1 over minus x will be 1 over x. So if you compare derivative when x greater than 0 and when x less than 0, you will see it will be the same, 1 over x, 1 over x. So we conclude that derivative of ln absolute value of x will be derivative of ln x will be equal 1 over x. So whenever you find absolute value inside the ln, you need to find the derivative, just take it as normal without absolute value.